What we'll be looking at is 3D projections. So basically how to show or how to view 3D images on a 2D screen. So let's begin with this. So if you look at any cube or a cuboid from the front, it'll basically look like a square on the screen. But in reality, it's not a square. It obviously rotates, and you can rotate it along whichever axis you want, your X, Y, or Z axis, and you can obviously translate it and move it around into your screen, outside your screen, and stuff like that. So in today's video, we're gonna look at how to do that and how these calculations are made. So the easiest idea that I can give you is so the front view of your cube obviously looks just like a square. If I rotate it a little bit, so now you can see that there's the line of the first front face, as well as the line of the back face, like the face that's furthest away from you, and the line connecting those two faces. Now that length is not actually the length of, it's not the actual length on that 2D plane. So this line is actually much shorter. So those calculations are what we're going to be looking at using something called perspective projection. So I'll quickly jump into the code and show you what exactly it does. So um, CG Lab 6. So what you get is a basic wireframe cube. So what this means is that the big face, that's it's basically a 3D cube, but it's a wireframe of it. So it's not a solid thing which is filled with color. It's just the outline of it essentially. The biggest square is the front face, and the smallest square is the back face, and you have your other sides as well. So as soon as you enter the image, you press any button and you get the options of translating, scaling, and rotating. So let's begin with scaling the image. So let me just scale it to say, I'm going to reduce its size by 0.5 along the x-axis, increase its size by 0.4 along the y-axis, and leave the z-axis as it is. And let's see what output we get. So there you go. So as you can see that all the points that are there, they have been shifted or changed, but at the same time the perspective or the relationship between points has remained the same. So what you need to understand here is that it all depends on how you view the image, right? So right now we're kind of imagining that the person is viewing the 3D object from the center. So therefore, if I translate it, okay, let's go back to paint here and let me try and figure out whether I can get a understanding of that. Okay, so suppose this is your image and you're looking at it from the front. Okay, so when you're looking at it from the front, it's essentially just a square, right? Like this. Now if the image is moved to this place and you're still standing over here, wait, let me mark a person over here. Yeah, so for this person, now if the now while this cube is obviously in front of him, it looks like a square. If it goes here, it no longer looks like a square. It looks more like this 3D thing. I'm not sure if you can see this. It essentially looks something like this, correct? Where this person will be able to see these two lines, this line, and everything, not just the square face. So that's what's going to happen when we translate this image actually. So let me just scale it back to its original size. So scale 1, 1, and 1. So we have our original square back. Now let's do a translate this thing. I'm going to move it to the right a little bit. So that will be my X. I'm going to move it by 0.5. I'm going to leave Y as it is and Z as it is. And that's the image that you get. So now if you're looking at it, if you're looking at this same cube as it was, so essentially for us it still looks like a square, right? You can see that this outermost box is still covering all the stuff behind it. So from our perspective, it doesn't look like anything's changed, but for someone looking from another side, this is what it would essentially look like, because the box has been shifted to the right by 0.5 of the total thing. So similarly, let me just again get it back to the base position. So let me translate it back to 0, 0, and 0. And let me just give a quick rotation to show you what happens. So now when I say rotate X, it essentially means rotate about the X axis, and rotate Y is about the Y axis, rotate Z is about the Z axis. So let's rotate about the X axis by say 45 degrees. So what that would essentially do is so this is our base, right? This is 0. And what 45-degree rotation will do is basically bring it forward somewhat like this, right? And that's what we're going to see. So 45, others are going to be 0. And you can see that the box essentially kind of moved forward. You have this particular line, and the line of the furthest side are kind of overlapping, which is why you can't see it. But if you can picture this, it's essentially a cube that's been like turned towards you 45 degrees forward, and that's the kind of thing that we're looking at. So let me just quickly rotate this back and show you a rotation along a different axis. So 0 along that, 0 along that, and 45 along that. Let's see what that does. So yeah, the z-axis here is according to the right hand rule. So the right hand rule is essentially your thumb pointing, your right hand's thumb pointing towards the right. That's your x-axis, y pointing into the screen, which is your your index finger pointing into the screen, which is the y-axis, and the middle finger pointing up, which is the z-axis. So you're essentially turning the cube along that axis, and this is the kind of figure that you get. Like you're taking the cube and you're just turning it by 45 degrees. So that's what the code does. Now, looking at what exactly is happening in this thing is very similar to lab 6 if you would have if you've been following our videos. So we have different functions like the scale, translate, and rotate functions, where we make one matrix which has all the values that are there. So the difference between a 2D and 3D thing is, now in 2D we had 3x3 matrices, in 3D we have 4x4 matrices. So you can see the 4x4 matrix over here. For scaling, we just put x, y, z values depending on what scale you want to change it to. And for the translation, we have it in the last column. And for the rotation matrix, you have cos A and sin A values being placed in different places depending on which axis you want to rotate it about. The main difference between 2D and 3D transformations is this particular function, which is the projection function. So here what we do is we have a few details like the field of view and what viewer distance, like where the viewer is looking from basically. Now the field of view is essentially how much of the object we can see from this point. So if say a cube was very very close to your face, you think that like everything around you is just that color, right? So essentially um, this, okay, this. So this is what you would see if you're very close to this thing, which is basically your viewing distance. Now, field of view is till what angle you can see. So for example, suppose we have this guy, we're going to name him Bob, obviously. So Bob's view is essentially something like this, okay? So now if I rotate this in such a way that these points are going out of the view, that means that right now when he looks at the box, he won't be able to see these points, but he'll be able to see the rest of the box. And that's where the field of view comes into picture. So anyway, back to this. How we get the 3D to 2D transformation is basically we have to get rid of that Z factor, right? And that is done using this factor. So what we do is we convert our X coordinate from 3D to 2D, Y coordinate from 3D to 2D. Z is made 1 by dividing it, and the last row becomes zeros. So this is essentially what needs to be done, and that's about it. This is just the code, the driver code essentially. So we have the 8 points that make up a cube, and we have the connections between those 8 points, like which 1, 2, 3, 4, 5, 6, right? So 6 sides, and which 4 points make up which side and stuff like that. We have the basic angle, rotations, translational scales. So scales have to be 1, not 0, obviously, and so on. Then we just have, we're using pygame, so we've added an event listener for button clicks, button press, key downs. And again, so you start with your cube, just press any button on your keyboard, and then you can translate it. So I'm going to translate this minus 0.3, translate y, say 4, and translate z 0. And oops, it went too high. Let's repeat that, my bad. Translate minus 0.3 and 0.4 and 0. Let's look at what that looks like. So there you have it. It's moved to the left and up. Left and up, yes, correct. If I were to change the view distance of the viewer, so now I'm at 10 units and I can hardly see the square. If I come closer to it, which will be say 4 units, and now I'm able to see the square better. So that's the basic idea. If I reduce my field of view, um, it's a similar effect, but there's very slight differences, which, as I explained using the paint thing, yeah. So that's about it. Code again will be freely available online, and links to the code will be mentioned in the description. Thanks for watching.